Hey, hi. Today I just want to talk a few things about the garbage collector. So, so to set up what a garbage collector is basically, so when you have a memory which is not referenced by any address, so I mean, like let's say you allocate a memory to a variable and you like deallocate it, but the physical memory is still allocated to the initial memory. So unless you free it, it won't be freed. So this is where the garbage collector comes in. So garbage collector runs more like a cron job. So it comes and it cleans the mm, physical memory which is not referenced by any variable in code. So there are few languages which do not have garbage collector, which do. There are few languages which use garbage collector at its core. So the lower languages don't use garbage collector. So C++, you have to like free up your own memory. Like you have to entirely clean the memory. So in Rust, uh, it's uh, in Rust, it's like scope to the execution. So once the execution of the variable is done, it will be freed up. It's nothing related to garbage collector. But in case of Python and Java and other languages, you have to like the garbage collector will come and like clean the whatever uh, physical memory that is unreferenced will be clean. So here is where the latency adds up. So since the garbage collector is a external process running and it kind of reaches the entire execution of the code and it comes and cleans the memory and in this time you can't do anything, so the CPU is installed. So this introduces a lot of latency in systems where there is a very high importance in latencies. So especially in like the inference side of things, the model load and model execution time, this piles up a lot. So this is where the need for going low level in uh, comes up. So when we are writing systems which are um, latency aware, we have to make sure that we manage our memory pretty well and not use a garbage collector for doing it. So we have to either go with a low-level language such as C++, or Rust. So what this language provides is we have a deterministic memory, like we don't rely on the garbage collector or any external process to free up our memory or do anything, any sorts of that thing. So we are in full control of our memory. We have to allocate it, we have to deallocate it, and like Rust does it of in a different way, but C++ you have to allocate and deallocate it. In Rust, it will like automatically delete once the execution uh, cycle is done. So this is like a uh, it adds up a initial development latency, but like there's an effort involved in writing the code, but it cuts it source performance on system scale. So yeah, this is on how GC kind of uh, it adds up the memory. So here is a cyclic collector where uh, it pauses all the threads like for a long period of time, which spikes up the percentile 99 latency. So there are the few areas that we are keen to look at, like where having a GC will have a major impact. So in model influencing, it will have a major impact, and not having a GC will give us much better results, as proven by the previous slides. So it cuts all this microsecond latencies, which will add up when the data size is like kind of big. We're loading a lot of uh, data at once. Yep, that's all for today. So for systems which are latency aware, don't use a collector, delete the data manually, or manage your data properly. Yeah.